Another way that I could be introduced to this idea is that if I'm given a point and some information about another line. So from this information, can I find an equation line that satisfies this information? Well, I have a point, but it's also telling me that I have a slope that's parallel to y equals 2x plus 1. So I think I have a point. Well, I know I have a point. I think I have a slope. And if I have a point and a slope, I can use a point-slope equation of the line. So do I really have the slope? What do I remember about parallel lines and their slopes? Their slopes were the same. And since this is in y equals mx plus b form, that 2 right there is the slope of every line that's parallel to that particular line. So I do have a slope. So from there, let's go ahead and use our point-slope form of the equation of a line, which is a y minus y1 equals slope times x minus x1. Again, where the x1 and y1s represent a known point we already have on the line. And we do. We know that this point is on the line. So let's fill in what we have. Y minus a 1 equals a slope, which is a 2, times x minus a minus 3. There's my point slope form of the line. I'm just going to kind of clean it up a little bit. Y minus 1 equals 2x. That becomes a plus 3 plus a 6. Let's add 1 to both sides. So now I have the equation, and a simplified equation of y equals 2x plus 7 happens to also be in point slope or in slope intercept form. So I can graph that line fairly easy from this point forward. But I want you to understand what the magic was behind it. And it wasn't magic. So we're going to show you what happened is we started with a point and we started with an obscure reference to its slope. Just from that information, we were able to find a line that matches that information. It's kind of cool.